Hello there everyone, my name is Dex Kamitan and today we're going to talk about independent t-test. This is a two-part video. For the first part, we will define what it is, talk about its common uses, its assumptions, its hypothesis, and its test statistics. For part 2, we will go over to SPSS to compute for t-test. Now, the independent samples t-test compares the means of two independent groups in order to determine whether there is a statistical evidence that the associated population means are significantly different. The independent samples t-test is a parametric test which goes by the name of independent measures t-test, independent samples t-test, independent t-test, student t-test, two-test t-test, or rather two-sample t-test, uncorrelated scores t-test, unpaired t-test, and unrelated t-test. Now, the variables used in this test are known as the dependent variable or the test variable and the independent variable or the grouping variable. Now, the independent samples t-test is commonly used to test the following, or rather number 1, statistical difference between the means of two groups. For example, you could use an independent t-test to understand whether first-year graduate salaries differed based on sex. Your dependent variable would be first-year graduate salaries, and your independent variables or variable would be sex, which has two groups, males and females. Alternately, you can use independent t-test to test the statistical difference between the means of two interventions. For example, you want to understand whether there is a difference in math test scores between students who received math anxiety counseling and those who did not. In this case, your dependent variable would be math test results, and your independent variable would be math anxiety counseling, which has two groups, students who received it and students who did not, or students who received it, which is also your experimental group, and students who did not receive it, which is also your control group. Now, an important note when you want to use the independent t-test is that it can only compare the means of two and only two groups. It cannot make comparisons among more than two groups. If you wish to compare the means across more than two groups, you will likely want to run an ANOVA. So, when you choose to analyze your data using an independent t-test, part of the process involves checking to make sure that the data you want to analyze can actually be analyzed using an independent t-test. You need to do this because it is only appropriate to use independent t-test if your data passes 6 assumptions that are required for an independent t-test to give you valid results. In practice, checking these 6 assumptions just add a little bit more time to your analysis, requiring you to click a few more buttons in SPSS statistics when performing your analysis, as well as thinking a little bit more about your data, but it's not a difficult task. But before I introduce you to these 6 assumptions already written here, do not be surprised if when analyzing your data using SPSS statistics, one or more of your assumptions are violated. That is not met. This is not uncommon when working with real-world data rather than textbook examples, which often only shows you how to carry out an independent t-test when everything goes well. However, don't worry, even when your data falls or fails certain assumptions, there is often a solution to overcome this. First, let's take a look at these 6 assumptions. Assumption number 1 is that your dependent variable should be measured on a continuous scale. That is, it should be measured at an interval or ratio scale. Examples of variables that meet this criterion include study time, which is measured in hours, intelligence, which is measured by IQ score, exam performance measured from 0 to 100, and weight measured in kilograms, and so forth. So, assumption number 2 is that your independent variable should consist of 2 categorical independent groups. Example independent variables that meet this criterion include sex, which has two groups, that is male and female. Enrollment status, which has two groups, full-time students or part-time students, and a certain type of intervention, which also has two groups, your intervention group and your control group, and so forth. So assumption number 3 is that you should have independence of observation, which means that there is no relationship between the observations in each group or between the groups themselves. For example, there must be different participants in each group with no participant being in more than one group. This is more of a study design issue than something you can test for, but it is an important assumption of the independent t-test. If your study fails this assumption, you will need to use another statistical test instead of independent t-test. For example, you can use paired sample t-test. Assumption number 4 is that there should be no significant outliers. Outliers are simply single data points within your data that do not follow the usual pattern. For example, in a study of 100 students' IQ scores where the mean score was 108 with only a small variation between students, one student had a score of 156, which is very unusual and may even put her in the top 1% of scores globally. The problem with outliers is that they can have a negative effect on the independent t-test, reducing the validity of your result. Fortunately, when using SPSS to run an independent t-test on your data, you can easily detect possible outliers. If you want a quick video on what to do with outliers, refer to our previous video entitled Outliers Detecting and Removing Them in SPSS. Assumption number 5 is that your independent variable should be approximately normally distributed for each group of the independent variable. We talk about independent t-test only requiring approximately normal data because it's quite robust to violations of normality, meaning that this assumption can be a little violated and still provide valid results. You can test for normality using the Shapiro-Wilk test of normality, which is which is easily tested for using SPSS statistics. If at this point you are nose bleeding with so many technical terms, get yourself a piece of tissue and don't worry about this because everything will be shown in the part 2 of this video. Assumption number 6 is that there needs to be homogeneity of variance. You can test this assumption in SPSS statistics using Levine's test for homogeneity of variance. Again, do not fret, I will show you how to test for homogeneity in the second part of this video. Now, you can check assumptions 4, 5, and 6 using SPSS statistics. But before doing this, you should make sure that your data meets assumptions number 1, 2, and 3, although you don't need SPSS statistics to do so. When moving on assumptions 4, 5, and 6, I suggest testing them in this order because it represents an order where if violation to the assumption is not correctable, you will no longer be able to use an independent t-test, although you may be able to run another statistical test on your data instead. Just remember that if you do not run the statistical test on this assumption correctly, the results you will get when running an independent t-test might not actually be valid. So, as I have mentioned earlier, independent t-test is commonly used to test statistical differences between the means of two groups and statistical differences between the means of two interventions. So, the null hypothesis and alternative hypothesis of the independent samples t-test can be expressed in two different but equivalent manners. First, HO, the population means from the two unrelated samples are equal. The first alternate hypothesis could go as the population means from the two unrelated groups are not equal. Now, the second way you can express your hypothesis for independent t-test is by saying that there is no significant difference in the dependent variable between group 1 and group 2. You should be supplying the words dependent variable and group 1 and group 2 with whatever are applicable in your study. So, in most cases, we are looking to see if we can show that we can reject the null hypothesis and accept the alternative hypothesis, which is that the population means are not equal. To do this, we need to set a significance level, also called alpha, that allows us to either reject or accept the alternative hypothesis. Most commonly, this value is set at 0.05. So the test statistics for an independent sample t-test is denoted as T. There are actually two forms of the test statistic for this test depending on whether or not equal variance are assumed. SPSS produces both forms of the test, so both forms of the test are described here. So note that the null and alternative hypotheses are identical for both of the test statistics. And to reject the null hypothesis, the p-value should be less than 0.05. Now that we have described and defined t-test, described its common uses, discussed its assumptions, hypothesis, and test statistic, we should now head on over to SPSS to compute for t-test or to compute for independent samples t-test. Let us say you want to use an independent t-test to measure if there is a statistically significant difference in the marital satisfaction of couples who married for love and couples whose marriage were arranged. So you have 16 couples who married for love in our sample and 15 couples whose marriage were arranged. So in order to use an independent t-test, your data should pass six assumptions. The first assumption is that you need to have one continuous variable or one continuous dependent variable. We have marital satisfaction, which was measured by a scale, and these are the individual scores of the couples. So we already this establishes our data passes the first uh, assumption. The second assumption is that you need to have independent categorical and one independent categorical variables that has precisely two levels or two groups. It cannot have more than two because you will not be able to use independent samples t-test if you have two or if you have three or more levels of the independent variable. So in our case, we have two groups or rather one independent variable, that is the type of marriage, and two groups, meaning you have love, those who married for love and those whose marriage were arranged. The third assumption is that we should have unrelated groups. So each participant or participants in each groups are unique, or in each group are unique, meaning not one participant uh, belong to both the love group and the arranged marriage group. So the next thing that we have to check on are outliers, normality, and the assumption of homogeneity. So in order to check for assumptions number 4 and 5, outlier and normality, what you need to do is to go to analyze, go to descriptive statistics, and then click on explore. Make sure that your dependent variable is in the dependent list box, and your independent variable or your factor variable should be in the factor list box. So check on statistics and make sure that you have checked on outlier. Go to plots and make sure that you have checked on normality plots with test. And then click continue and then click OK. All right, you'll see an output window here and immediately go to the test of normality. As you can see, what you have to do is to pay attention to the significant levels in the Shapiro will test. As you can see here, um, the group for the arranged marriage group has a significant level of 0.293. This is okay because we don't want any significant. We don't want to see a p value of 0.05 here and below because it means that your um, data significantly deviates from the normal. So as we can see here, our arranged group is above 0.05, so it resembles normality. However, our love group here has a p-value of 0.015, meaning our data for the love group significantly deviate from the normal. All right. So what you have to do next is to check whether you have outliers. Because as you know, outliers can influence the distribution of normality of your data. So I need you to go look at this plot and check if you have any outliers. As you can see, we have an outlier here. In the love group in cell number 16. So what you have to do is to go back to your data and delete cell number 16 because it is an outlier. Or yep, the score uh, of this couple is an outlier. So delete it and then again run your descriptive statistics and then go to explore using the same setting and click on OK. So as you see now, in the test of normality, both are no longer both p-values under the Shapiro will test are no longer significant. This means that our data are somewhat normal. All right. So now that we have checked on assumptions 4 and 5, we can now go on to check assumption number 6, the assumption of homogeneity. So you can actually check for homogeneity if you run independent t-test. So go to analyze, go to compare means, and then select independent samples t-test. All right. So in your test variable, make sure you have selected marital satisfaction. In the grouping variable, make sure you have selected type of marriage and click on define groups. For group number 1, type on love because our first group is uh, those couples who married for love. And for group number 2, type in arranged because the second group is composed of couples whose marriage were arranged for them. So click on continue and then click on OK. All right. So go and look at the t-test output. So as you'll see, you'll find the group statistics table here, and it tells you how many sample you have, the mean of each group, the mean marital satisfaction of each group, and the standard deviation as well as the standard error mean. So as you can see, those who married for love has a higher marital satisfaction than those whose marriage were arranged for them. So, however, although the mean or there's a big difference between the scores here. You cannot say that they are statistically significant. In order to do that, you need to check on the significant levels. So, but before that, check on the Levine's test for equality of variance. So, because our significant level for the Levine's test uh, is above 0.05, this means that we can assume that there is equal variance. If this assumption is uh, if you violated this assumption, you can actually, or when you're significant, when you have a significant level here, or your p-value is below 0.05, then you can just look at the t-test for equal variance not assumed. But in this case, since we have not violated, or our data passed the assumption of homogeneity, then what you have to look at is the t-test p-value of marital satisfaction under equal variance assumed. So it's here. All right. So since the significant level, or the p-value, is lower than 0.05, we can assume that there is a statistically significant difference between the marital status of couples who married for love and couples whose marriage were arranged for them. And that is how you use independent samples t-test in SPSS. Thank you for watching.